Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at how to graph exponential functions. Alright, so the instructions are for us to graph the given exponential function using the specified x values. Alright, so let's say we have the exponential function y equals 2 to the x. Alright, so we're going to be generating a table of values using this function, and then we're going to graph the resulting coordinate pairs. Alright, so let's say that we're to graph this function y equals 2 to the x using the x values, -1, -1, 0, 1, and 2. Alright, so these are the values we're going to be plugging in. Alright, so we have x, and then we're going to be carrying out computation for the y value, y equals 2 to the x on the second column. Alright, so let's start with the first one, which is -1. So if x is -1, what is y going to be? Y is going to be 2 raised to this, so replace the x with the input value, which is -1. Now, using the reciprocal property of exponents, this can be rewritten as 1 over 2 to the first power, which is just 1/2. Alright, so anytime you have a negative exponent associated with a term, it gets reciprocated. If it's in the numerator, it goes to the denominator position. If it's in the denominator, that term with a negative exponent goes to the numerator position. Alright, so that's known as the reciprocal property of exponents. Alright, so now we have an ordered pair. So we're going to be putting the ordered pair in the last column, xy. First ordered pair is for -1. We have 1/2. Alright, so let's move on to the next input value for the next row. For that one, we're going to be working with 0. Okay, so y of 0, I'm going to plug in 0 into x, is going to be 2 to the 0th power. And any non-zero number raised to the 0 is just simply 1. Alright, so our ordered pair here is going to be 0, 1. Alright, now let's move on to the next value. The next value that we're going to be working with is 1, +1. Okay, so let's plug in +1 into the function. So we're going to compute y of 1. So that will simply be 2 raised to the first power. 2 raised to the first power is simply 2. So we're going to be graphing the ordered pair 1, 2. We have one more ordered pair to generate, and that one will be using 2. So our input value x is going to be 2. So y of 2 is simply going to be 2 raised to the second power. Alright, 2 raised to the second power is just 2 times 2, which is 4. So we have the ordered pair 2, 4 for the last point that we're going to be graphing. Alright, let's go ahead and set up our coordinate system. So we can just take a look at the y and the x coordinates to see how we would like to set this up. If you notice, y goes from negative to positive. Alright, just -1 to +2. But the y is just strictly positive. So if the y is strictly positive, we can situate our x-axis in a lower position. Alright, and then shift the y-axis somewhat to the left, since we just have one negative value for the x. Alright, so let's label our axis. So this is our x-axis right here, and this is our y-axis, so x and y. Now the way we're going to calibrate it is as follows. For the x-axis, let's make every 3 tick marks a unit. Okay, so 1, 2, so that will be -1 right here. So it's nicely spread, and then 1, 2, that's +1. And then 1, 2, 3, that's +2. Alright, and then that's 0, of course. And then for the y-axis, let's make every 4 tick marks 1. Okay, so 1, 2, 3, that's +1. And then 1, 2, 3, that's +2. 1, 2, 3 as positive 3. And then 1, 2, 3 as positive 4. All right, let's go ahead and graph the points. I'm going to graph it in blue. The first one is -1 goes to 1/2. So -1 goes to 1/2. This is 1/2 right here, right in the center between 0 and 1. And then 0 goes to 1. 0 goes to 1. All right. And then 1 goes to 2. All right. Notice how the rate of change is increasing. And then 2 goes way all the way up to 4 right there. Bam. So that's basically the trend that exponential functions display. All right, so let's shift the coordinate system a little bit to the right so we can display the asymptotic behavior that exponential functions display as they approach the x-axis. So we're going to go ahead and connect the dots now. All right, so when you connect the dots, it's going to look something like this. It's just a rough sketch. Okay, so something to keep in mind, so this is your exponential function, y equals 2 to the x, is that the function gets infinitely close to the x-axis but never actually touches it. Okay, all right, so let's go ahead and specify our domain and range. So let's start with the domain. Think about the domain as the width of the graph. All right. All parent exponential functions of the form y equals a to the x have identical domain and ranges. All right, so the domain is how far to the left and how far to the right. It goes to the left forever, so that's -infinity. To the right forever to infinity. So our domain is going to be -infinity to infinity, or you can write it as all real numbers, or just use the notation big R like that. All right, okay, and then the range is the vertical span of the graph. How low can you go and how high can you go? In this graph, you get infinitely close to the x-axis without touching it, so that's 0 all the way up. So you go from 0, you're thinking about the vertical span up and down. Okay, so you go as low as infinitely close to 0 without touching it, and then go up forever to infinity. Or you can write this as y is greater than 0. Okay, or you can even use interval notation for this. Well, we already have that right there. Or y is greater than 0 as an inequality, and interval notation 0 to infinity. Okay, so now let's give you a practice problem to try out. Okay, so we'd like you to try out this problem, number 2. We'd like you to graph y equals 3 to the x using the same input values, domain values that we used for the original example, question number 1. Okay, we're going to go from -1 all the way to 2, and then specify what the domain and range of the resulting graph is. So go ahead and pause the video presentation at this time and try out the problem. All right, so here goes the answer to question number 3. You can see the input-output table, the graph, and the domain and range. So how well did you do with this practice problem, number 2? Specify it in the comment section below. If you have any questions for us, let us know in the comment section. We'll be more than glad to assist you. So this is basically how you generate the graphs of exponential functions in the parent format. Thanks so much to all those who support our channels with your likes, comments, and subscriptions. We appreciate it. Tons of support resources can be found at mathgotserved.com. Thanks again for watching. We'll see you in the next video. Goodbye.